They destroy everything in their path: stars, light, even time. Invisible, unstoppable, and terrifying. These are black holes, and the universe's deadliest predators. Birth of the monster. In the infinite cosmos, stars are born from clouds of gas and dust, collapsing under gravity's relentless pull. Over millions of years, these stars live vibrant lives, fusing hydrogen into helium, powering light across galaxies. But life is fleeting for the most massive stars. When nuclear fuel runs out, gravity claims victory. The core implodes, compressing matter into densities beyond comprehension. The outer layers explode as supernovae, releasing unimaginable energy, briefly outshining entire galaxies. For those remnants massive enough, a black hole is born. These are not ordinary objects. They are regions where gravity warps spacetime to such extremes that the familiar rules of physics break down. Approaching a black hole is to face forces capable of tearing atoms apart, stretching matter into thin threads, and bending time itself until it almost stops. This is the birth of cosmic monsters, the ultimate predators of the universe. Even now, black holes remain partly invisible. Their presence is inferred through the behavior of nearby stars, glowing accretion disks, and high-energy emissions. They are silent, patient, and utterly indifferent to the universe around them. To survive near one is impossible, to study one is to peer into the abyss. Every black hole is a doorway to extreme physics, revealing the power, danger, and mystery of the cosmos. Anatomy of darkness. Every black hole has a structure defined by extreme forces. The most crucial boundary is the event horizon, the point of no return. Beyond this, nothing can escape, neither matter nor light. At the center lies the singularity, a point of infinite density, where space and time collapse. Physics as we know it ceases to function. Black holes vary in size and form. Stellar black holes arise from collapsing massive stars and typically range from a few to dozens of solar masses. Intermediate black holes remain elusive, possibly lurking in dense star clusters. Supermassive black holes, millions or billions of times the mass of our Sun, dominate the centers of galaxies, influencing the motion of billions of stars and shaping entire galactic structures. Time behaves strangely near a black hole. Close to the event horizon, time slows, and light curves in dramatic ways. Matter spiraling into a black hole forms an accretion disk, superheated to millions of degrees, radiating X-rays and gamma rays. Jets of energy can erupt from the poles, traveling near light speed, a spectacle of destructive beauty. The gravity is so intense that even photons follow curved paths, bending light and creating eerie distortions. The singularity represents a terrifying unknown. It is a place where densities are infinite, tidal forces would shred anything instantly, and our understanding of reality breaks. Scientists theorize that quantum gravity might offer answers, but for now, it remains the ultimate cosmic enigma, dangerous, invisible, and incomprehensible. Listening and watching the abyss. Black holes have long been invisible, but their presence can be detected indirectly. Observing stars orbit unseen companions, measuring X-rays from accreting matter, and detecting gravitational waves allow us to study these cosmic predators. In 2015, LIGO detected gravitational waves from colliding black holes billions of light-years away, letting humanity, here, spacetime itself vibrate. The Event Horizon Telescope provided the first direct image of a black hole in 2019, revealing a glowing ring around a dark shadow. This was more than a photograph, it confirmed decades of theoretical physics and allowed scientists to study extreme gravity directly. Hawking radiation suggests that black holes slowly release energy, hinting that information may not be entirely lost, challenging our understanding of physics. Gamma-ray bursts, possibly linked to black hole formation, are among the most energetic events in the universe. A single burst directed at Earth could sterilize life. These cosmic monsters operate on scales and energies that dwarf human comprehension. Their danger is abstract but real, a reminder that the universe is not always hospitable, and that destruction and creation often walk hand in hand. Titans and cosmic threats. Supermassive black holes dominate galaxies, their gravitational influence shaping star formation, galactic motion, and the evolution of entire star systems. Quasars, powered by these giants, emit more energy than entire galaxies, jets of plasma slicing across space. The Milky Way's own Sagittarius A** silently commands the orbits of millions of stars. Intermediate black holes may form from dense stellar clusters and could seed supermassive black holes. Stellar black holes continue to form from massive stars, their presence marked by X-ray binaries, gravitational waves, and the occasional supernova. Approaching a black hole is fatal, but theoretical studies of wormholes and quantum effects hint at possibilities beyond current physics. Colliding black holes create gravitational storms that ripple across space, their echoes reaching us billions of years later. Dark matter may interact with black holes, influencing galactic structures in ways we cannot yet measure. Every black hole represents both the ultimate threat and the deepest insight into the cosmos. Beyond the horizon, black holes challenge everything we know about reality. The singularity defies physics, the information paradox puzzles scientists, and quantum gravity promises answers yet to be discovered. Some theories suggest that black holes could be gateways to other regions of spacetime, though such wormholes would be unstable and fatal to any traveler. The universe itself may be influenced by black holes in ways we are only beginning to understand. They hold clues to the structure of galaxies, the nature of dark matter, and the ultimate fate of the cosmos. Each discovery brings new questions, revealing a universe far more violent, dangerous, and mysterious than we ever imagined. Black holes are both destroyers and teachers. They annihilate matter, distort time, and warp reality, yet they illuminate the deepest truths about existence. From stellar deaths to supermassive giants, from gravitational wave echoes to gamma-ray storms, they represent the ultimate cosmic danger and the pinnacle of scientific discovery. In studying black holes, we confront our own limitations, witnessing the extremes of nature, the fragility of life, and the profound mysteries that define the universe. They are silent predators of the cosmos, invisible yet omnipresent, shaping galaxies and challenging humanity to understand forces far beyond our control. They remind us that the universe is alive with energy, violence, and incomprehensible power. In darkness, there is both danger and revelation. Black holes are the ultimate test of human understanding, the darkest objects in the universe, and the most powerful keys to the secrets of reality.